Okay, good morning, good afternoon, good evening, everybody. My name is Seth Paskin, and I am the Director of Technical Marketing for BMC's Digital Service Operations Group. Today, this is our ongoing Best Practices webinar series. We run these webinars every 2 weeks at 10 a.m. Central Time in the U.S. On a variety of topics. We have a calendar posted on BMC Communities where we post the topics for future sessions, as well as links to recordings from our previous sessions, which started back in August of last year. So today's topic is on our setting up TrueSight Orchestration for scalability and availability. And during my intro, I was waiting because my guest of honor has not quite joined yet. I should say guests of honor, Umesh and Rangananth.
Today we will discuss a little bit about how TSO can be designed or configured for different scenarios. Some companies would like to have, they have not much load on the system, but they want to make sure the system is highly available. When there are some companies, there could be heavy load on the system. When I say load, we are talking about a lot of jobs running at the same time, thousands of jobs running at the same time. So I'm in the WebEx right now. So what we will talk about is just few ways to kind of design TSO based on the requirements. Okay, so as I said, you have a requirement that's requires high availability, but there are other requirements where you have a lot of events coming in, like an event storm. That means you have a lot of jobs running in the system concurrently. So how do you configure and design your system? So can we go to the next slide? Okay, so as you all know, this is the simple grid. This grid is nothing but a collection of CDPs, HACDPs, activity processors, and LAPs. So this is the simplest grid that people usually can install in their development environment. So what you see at the bottom is a table that will show you the performance numbers that we have tested in our labs. So just keep in mind, these performance numbers are, it's a controlled environment, obviously. One of the aspects of TSO is that, when a job completes, how much time it takes to complete is heavily dependent on it's the applications that it's trying to integrate with, be it an ITSM system like Remedy ITSM, or a Blade Logic application, or PowerShell commands, or Active Directory, whatever it is. So its performance is highly affected by how the target applications perform as well. So there could be jobs that can run within milliseconds, but there can be jobs that can take seconds or even minutes. So, and then based on how the target application is loaded and how busy it is and how the network traffic is, your jobs can take a minute to 2 minutes or 5 minutes. It depends on the situation. So when I say we ran 32,760 jobs in 1 hour, it is in a controlled environment. When I say controlled environment, is like we didn't use any adapters, mainly because adapters introduce variability into our numbers. Because if Remedy ITSM takes longer time because it's very busy, then in a VM environment especially, then these numbers will change drastically. So we cannot compare from one test to another test, from one release to another release, if we have these variabilities. So we have what we call a mixed workflow. There's a typical workflow which has got a bunch of activities that are like switch activities and a bunch of for loop activities and all those activities that don't necessarily exercise adapters, but they exercise the platform's inbuilt accessibility XPath engines. Okay, and then we pass in a data which is around 1 megabit in size or 10 megabit in size, and we try to see how this whole thing performs. The next step was, like you will see in the subsequent slides, how this configuration where we have only one CDP compares to when you add more peers into the grid, and what happens if we hit a limit, how do we re-architecture the system. Okay, so let's go to the next slide. So in the next slide, you will see, okay, now this simple grid has two peers in the grid. So on a CDP and an HACDP. So this is meant for HA. So if CDP goes down, everything that you can do with CDP, you can do with HACDP. So basically, you have high availability. They don't have to be in the same data center, really. They can be in two different data centers. You can have both of them can be in the same data center as long as there are two different VMs or virtual machines or physical servers. We are good there, right? If you see the table, most importantly, when you have the numbers that are, you could run 32,000 jobs per hour when you have only one CDP. But then the same set of transaction load, when you add a second peer into the grid, the number goes down, the throughput goes down, how many you could run within 1 hour. The reason is because now if CDP and HACDP, they both are trying to communicate with each other, making sure that the job states are exchanged, and there's a lot of chatter going on between them. So there's a lot of CPU cycles spent trying to communicate with each other before a job is progressing from pending to in progress and completed state, right? So as you can see, even though it may not be CPU utilization is down, if you see it's down from 84 to 63% for each of the VMs, even the memory usage is high a little bit because there's extra additional communication going on between the peers. The throughput is also considerably down. Okay, so that is the reason why you have to be cautious. Like when you add a new peer into the grid, there is always confusion among customers. They say, well, I'm going to add a new peer because I can run more jobs. So that's not necessarily true in this case, because the whole grid concept is designed for high availability rather than more scale, horizontal scale for throughput. Okay, so let's go to the next slide. Okay, so now the next typical setup that we see in customers is okay, now we have high availability with two CDPs, but now I also want disaster recovery. So this is where you have two data centers, and then you have, now 4 peers in the same grid, okay? So you have a CDP and an AP in one grid. You have CDP, HACDP and an AP in the second grid. So if one data center goes down, you still have complete functionality, albeit maybe reduced to a certain extent, available. So as long as you have a load balancer that's redirecting traffic between two data centers, you are still able to perform all the things that you could perform earlier, right? But if you see the table in the numbers, because we added 2 more APs, activity processors, so the numbers went down some more. So what you could run, with 2 CDPs, you could run 10,000 jobs per second. You are now able to run per hour. Sorry, you are now able to run only 4,000 something jobs per hour. Okay, you can see the CPU utilization is down further because there's a lot more time spent synchronizing these peers to make sure that if one peer goes down, some other peer can pick up the what we call master persona When the master persona is basically that particular peer is the responsible for distributing the jobs to all the other peers in the grid and things of that nature. So, so now people will say, well, I really don't want this whole, reduce in throughput. So what do we do? So this is how the DR is, but let's go to the next slide, and we can see maybe some alternatives to help us with this issue. So here you see two grids, okay? So if you remember in the first slide, we had only one grid in one CDP. Now here you added two grids, and each has its own CDP. They don't communicate with each other. There is no relationship between those two. They are completely unaware of the presence of the second grid. But you have a load balancer sitting in front of them, so you can redirect traffic to either of them. As you can see, like this particular scenario is not necessarily useful when you have monitor adapters and you want HA for it, right? So monitor adapters typically end up, if you have two instances of monitor adapters, they are receiving events from the same source. They send it into the grid, and there is some deduplication logic implemented. So even though you have two instances of the same event coming in, only one event is picked up, and the second event is dropped, and only one job is kicked off because of that. But if you have two CDPs and they don't know the presence of the other one, they'll start running the jobs based on those events. So that's why you see in the last column, the event deduplication, it says no, okay, you don't have event deduplication. So if you have monitor adapters, you have to be very careful and decide, okay, if we have, how do we go about doing this, right? In the simplest answer would be like, if you have monitor adapters, I would suggest not using this architecture. But only if the calls are only coming via like REST API or Orca SOAP calls, then this is a very good architecture for increasing your throughput. You can actually double it. Because each of them, they really don't know what the other one is doing. You can really double the throughput. Okay. Let's go to the next one. So here we have HA and DR. So you're basically saying, okay, I'm going to have two grids, each in one data center. You can see there's a load balancer up top, which is redirecting traffic from one to the other. So in this case, again, your throughput will be a lot better than, 4 CDPs or 4 peers in the grid. Remember in the slide you had 4 peers, your throughput was like 4,000 plus jobs per hour. Here you still have like around 20,000 jobs per hour. Again, if you have monitor adapters, you have to make sure that the event deduplication will be hit. Okay. So those are some of the thoughts or suggestions that we have. Can we go to the next slide? So notes, prefer not to have more than 2 peers in the grid unless there's a requirement for HA and DR. Okay, so now if you add 4 peers, or your overall throughput goes down. So we always ask the question, if some customer says, okay, I have 4 peers in my setup, the first question we ask is, why do you need 4? What is that, and for a lot of the times we hear the answer that because we need to run more jobs. So as you can see, if you don't want to run more jobs, having 4 peers in a grid is not the answer to it. You have to kind of have different grids, maybe multiple grids is a better situation for you. Okay, so if you use multiple grids, if there is a requirement to scale horizontally. Okay. Now, event deduplication, even though I said no in the previous slide, there are ways we can kind of have multiple grids and then still be able to perform event-based job execution. we just have to make sure that, events coming into these grids are very unique. So the same event is not forwarded to both grids. That is also possible some ways, that if you have some kind of a logic upfront to say that, hey, this is something that this particular, you can kind of partition the event data, identifying maybe from some field, and say an event with this characteristic will go to only to grid 1, and the event with a different characteristic will go to grid 2. Okay, those are some of the options that we have. I think this is it. I didn't put any slides for the future. We have more exciting things. I apologize. We are trying to come up with containerized based support implementation for TSO, which will provide us more scalability than what we have right now. Okay, but we don't have that. But if you have questions, we can answer those questions to the panel or to the audience. I think that's it.
Okay, thanks, Ranga. So a couple things. We don't have any written questions in the Q&A window currently. What I'm going to do is, folks, I'm going to unmute the audience so that if anybody wants to ask a question, they can. But I do ask, if you don't have a question, just go ahead and mute your own microphone so we make sure that we don't get too much background noise. I would also like to ask, if people don't mind, in the chat window, just go ahead and respond with respect to the container point that Ranga mentioned. We're taking a strategy across the entire BMC, the entire automation and orchestration, as well as performance and security portfolio, that we are moving towards using containers, both for deployment of the agent as well as deployment of the system. And we're trying to get a sense from customers where they are with respect to implementation and utilization of containers in their environment. So while we're doing this, if you don't mind, in the chat window, just putting something like, don't use containers, just getting started, or mature deployment of containers, to give us some sense, that would be great. I don't know how to do a poll inside of the WebEx, otherwise I would do that and it would be a little more sophisticated. So let me go ahead and just unmute folks.
The presenter has allowed participants to unmute themselves. You can now unmute yourself by pressing *6.
No questions? All right. Well, in that case, if we don't have any questions.
Hey, Ranga, it's Gordon McKeown here. I know you and I, we've discussed before the conditions for the testing that you described on this call. Perhaps it's worth sharing with people the effect of adapter calls on the performance figures.
I don't have hard figures to provide, so definitely, the adapter calls do impact the overall throughput. So what happens is, when an adapter makes a request, it has to wait for the target application to respond. So that is a variable number from environment to environment, based on the time of the day, based on how that particular application is loaded, how busy it is. It can respond differently. So what happens is, the throughput number that you saw, be it like 10,000 or 30,000, that will change. When you add up cumulatively, jobs take longer to finish, which means the resources available, the memory utilization will go up, the resources available for remaining jobs goes down. So that means the overall there's an impact what numbers that you see, what we have shared, is probably, like an upper limit, so when you have adapters, your numbers will be lower. Definitely, if it's say 30,000, we have seen customers running around 20,000 jobs, per hour. That's definitely in the realm. So it's again from case by case basis. Did I answer that question, Gordon?
Yeah, that's good. Thanks, Ranga.
Yeah.
Thank you, Gordon. Any other questions? Okay. Well, then I'm going to go ahead and close the session. Let me just share this last slide. So thank you, Ranga, for the presentation today. As I mentioned, the event that's on BMC Communities, I will share the recording as well as Ranga's deck up on that. The deck includes these set of links. So I've linked to the TrueSight Orchestration playlist on YouTube, as well as documentation. If after the session closes, you have any questions, concerns, anything you want to know about either the the webinar series or the product itself, you can reach out to me directly at Seth_Paskin@bmc.com. And if I don't know the answer, I will get you in touch with the right person. With that, I want to say thanks everybody for attending. Thank you for bearing with us on the technical challenges we had at the beginning. And I wish you all a wonderful and happy evening, day, or afternoon, depending on where you are. Thanks so much.
All right. Thank you.
Thanks. Bye-bye.